code analysis for IV&V. And recently, because of the focus on cybersecurity and information assurance, it's also becoming IV&V for information assurance, as well as how static code analysis tools can be utilized to detect vulnerabilities in the code and make the systems more secure in the first place. And having in mind that NASA builds and maintains many systems where cybersecurity is of interest, both ground systems and control systems. So this is obviously an interesting topic. And this panel here is actually involving people that deal with information assurance or cybersecurity or static code analysis at IV&V in different ways. So each of the panelists will introduce themselves shortly and give a brief opening statement, and then we will have an open discussion on the current state and future direction of static code analysis for information assurance. So, Rich.
Hi, I'm Richard Brockway, and I lead up the information security mission assurance capability and the associated functions here for the program. And on this slide, really what I wanted to do was set the stage for the discussion today. I will be going over some of the other dimensions on this slide later today. And what's important are really some of the themes for this particular discussion are highlighted in the oval, the red ovals there. But across the top, if you look at you have a variety of life cycles: acquisition life cycle, system development life cycle, and then there in the middle section is really our structured IV&V technical framework. And the real message here is that static code analysis is one of several capabilities and tools that are necessary to help assure information assurance, information security, and security controls, which I'll discuss security controls, and happy to answer any questions about that as we go along. But it's one tool that can be used and should be used among other tools, and it should be used in conjunction with the human in the loop. So what's important, and you'll hear some of that further discussed, is the need for the analysts. And we have built up quite a capability here on our NASA missions to leverage static code analysis tools or set of tools, and then to perform analysis using that output. And later in the process, on the far right of this particular diagram, it's meant to also show another theme, and that is that even after a system has gone live, static code analysis is an important tool in performing vulnerability assessments and indeed even penetration testing of a live system. And so again, some of those themes I'll dive a bit more deeply into later, but I wanted to set the stage for some of the other folks here to elaborate on those themes.
And my name is Rick Hess, and I'm the Static Code Working Group lead here at the facility. For those that don't know, we do have a working group where we share ideas and concepts between different analysts that do static code analysis. So one of the things I wanted to quickly talk about was some of the initiatives that we have currently going on. Let me start by saying that the first thing that I wanted to talk about was we were trying to develop a tools capabilities matrix currently, where we have a list of tools that, static code analysis tools that check different things. As a result, we want to try to determine what tools check what types of issues so that we can determine what kind of coverage we can provide, what kind of assurance can we provide to our customer. By doing that, another initiative that we have is actually doing our own testing with the tools, writing an Oracle test script or a test script that basically has a bunch of different types of tests, and trying to push those against each of the tools so that we can guarantee that not only can we validate that this particular tool can find this problem, but we can also find out if there's other things that the tool may check for that it's not advertising, or if it's advertising that it does check for something that is a little bit different than when we thought. The next thing that I wanted to talk to real quick was the prioritization of the checks for a lot of these tools. Sometimes depending upon the project, things are more important than others. For example, buffer overflows may be more important than unused code to some projects. The last thing was we're also trying to develop a software quality objectives document to talk about the approach for the particular way we do static code analysis, involving maybe some of the ways we pick our tools and the checks that we use. And then the next slide talks about the challenges real quick. Just really wanted to touch on the fact that the tools aren't perfect. There's particular problems that we have, which is, tools have gaps in assurance. Some tools can stop analyzing a file after the first error that it finds. So we need to make sure that we're aware with that. Some tools don't work well with incomplete builds. That's one of our challenges here at the facility. We don't always get compiled builds. A lot of times we're not allowed to see all that, so they give us pieces. And then this last thing is some of these tools have resource limitations. So then it becomes a question of whether or not, or our analysts have limitations. So, whether or not our scope needs to be of a certain size, or if the time that it takes to do the tool may determine whether or not we want to use that tool. We're actually trying to get some feedback for the SQO initiative. That's coming along slowly. We still have it sort of in a draft state, but we've been presenting it, so we're continuing to get feedback for that. We're trying to make it work for different projects, which again basically talks about the prioritization of the tools. And then stressing the importance of the third-party code and making sure that we're also considering that as part of our analysis when we do it.
I'm Van Casdorph. I have a little over 19 years of IV&V experience here at the facility. About the last half of that as a project lead, responsible for planning IV&V tasks. And I'm here to talk about a specific challenge from one of my most recent projects. We try to address all results returned from static analysis tools when we can. You've heard several presentations today talk about why that might not be possible. In this case, when you're dealing with a very large code base, you might get a very large data set return from that code base. So you'll need to look at ways to reduce the set of messages that you're going to analyze. And the way that we've typically handled that is through changes in the scope, changes in the prioritization of the checkers that we're going to look at, using our historical knowledge of what checkers tend to return higher true positives than false positives, and also combining that with some tailoring to meet the specific needs of various projects, whether that's following particular standards checkers, as Ben mentioned this morning, or looking at some of the industry standards for common weakness enumerations, and things like that. But even with those kind of considerations being taken, you still might end up with a larger data set than it's feasible to analyze with the constraints of how many resources you can apply to the task. So, then you bring in the concepts of sampling within large groups of checkers, reducing the rigor at which you're looking at each of those messages. And, that gets you down into a range where you have the schedule and the resources available to look at the messages. So in this particular instance, on a very large ground system of about 3 million lines of code combined between C and Java, there was a little over 100,000 messages returned by the static analysis tool, and those messages span 260 unique checker categories. We had a constraint of a certain amount of time and 4 FTEs to look at that, so obviously we weren't going to get that full 100,000 messages looked at. So we employed some of those considerations where we looked at the prioritization of checkers, And next slide, please. And, we made some decisions specifically to descope low severity findings from the tool. Based on our knowledge of the system, we descoped 2 of the subsystems because of the maturity of the software functionality that was represented in those systems. We traded off against the SANS Institute top 25 most dangerous software error checkers, the top 10 security risk checkers. And when we reduced that set, we still had some message counts that were greater than 25, and for that we employed some sampling techniques. And next slide. And what it boiled down to is that for the resources that we had, the time frame that we had, we only had targeted 8,400 or so of those 100,000 messages, and actually put eyes on only about half of those. And out of that, about 25% of the messages were found to be true positives, but that left a significant number of potential software errors that were unanalyzed. And, that still is, a challenge that we have to address within the facility of how to better reduce a data set of that size to a manageable amount that we can analyze and still provide quality assurance to a project over a large data set. In this particular instance, it led to the developer actually adopting the static analysis tools into their development environment. So even though we couldn't analyze everything, we did have a positive influence on the project in that they changed their development processes to bring in a tool that they had previously not used to improve their software development.
My name is Katerina Popstojanova. I am Associate Professor of Computer Science at West Virginia University. My research interests are in software quality assurance, information assurance, and cybersecurity. And the part that I'm going to address here is the 2 capability development initiatives that myself and my graduate student Andrei Pershinsky has done in the FY13 and FY14, which are focused on static code analysis for information assurance, which is basically trying to find vulnerabilities in the code by using static code analysis. And next slide, please. As an academic, I cannot resist to give the statement, static analysis problems are undecidable, which basically means you cannot construct an algorithm that is going to provide a correct answer. That is why these tools have false negatives, so they miss some bugs and vulnerabilities, and also produce large number of false positives, as Van just said, on a very large project that's into the range of hundreds of thousands of warnings. So the FY13 Capability Development Initiative was focused on evaluating 3 commercial tools, which cannot be identified because of the license agreement for the purposes of this talk. But basically what Andrei and myself did is tested those tools on micro benchmarking test suite Juliet that's developed by NSA and made public by NIST, and it's a very nice benchmarking tool that allows you to say what's false positive, what's false negative in what the tools report, as well as we use 3 large open source software programs with known vulnerabilities to compare the tools. So at our, I would say, not very big surprise, but very big disappointment, the tools didn't produce as good results as we expected. Some CWEs, common weakness enumerations, were detected by all 3 tools, others by combination of 2 tools or a single tool, while some were missed by all 3 tools, which is false negatives. And static code analysis, obviously, as Rich was saying, is an important part and should be used as a part of the IV&V cycle. but it's not enough to have assurance that the software is secure, and it's only one of the many pieces. So following this up, in the last year, almost a year, we are working into developing methods and implementing them in a tool which we call SCAPE, Static Code Analysis Prioritization Engine, for flexible, adaptable, and efficient prioritization and analysis of messages produced by static code analysis tools, because the main goal here is how you prioritize the practical problems, as Sven described. And the tool is providing decision support to the analysts that do this job. It was developed iteratively in the process in which the stakeholders were constantly in the loop, including Van and Brandon Bailey. The highlights of this specific tool is it can work both online and offline, which in cases when the IV&V deals with projects that are proprietary and cannot be accessed out of the developer's facilities. It uses the industry standard criteria such as known CWEs, SenseTop 25, and so on, as well as NASA IV&V specific things like the SQOs that Rick just mentioned. It keeps logging history for assurance purposes and links to the orbit issues if these warnings becomes an issue. And this is just to give you an idea of the SCAPE architecture. Obviously, it's a 3-tier architecture with GUI that tries to make things easy for the user. Database as a backend. And in addition to the common things of administration and configurability, it allows to build work assignments for the analysts and peer reviewers. Also allows filtering and ranking of the messages based on different criteria, and selection of prioritization of messages to be used based on heuristics and data mining approaches, as well as visualization of the results in the form of graphs. So in some sense, this is one very small piece into how one may approach making the whole process of using static code analysis for information assurance and support the analyst's daily work.
Good. So my name is Marcus Fisher. So I guess this is really the lead-in now to, this is not a report out of, okay, here's our next steps. I can go over these bullets and then we'll end here. We're utilizing the concept of this panel to try to stimulate discussions, ideas, thoughts, heartburn, whatever it might be, around the topic of static code analysis for information assurance purposes. Can we find vulnerabilities before they become exploited? And so you heard numerous threads of discussions here from the folks. And so what are some of the discussion areas? Well, you know, in listening to some of the things that were said, and we talked about this, of course, previously, threw down some ideas on a PowerPoint chart, not for lecture purposes, but to try to stimulate some ideas. Like, for example, how do we make ourselves more efficient? You heard that theme of it's an undecidable problem. You heard the theme of these tools. If you utilize these tools, it produces a lot of output. So how do we filter this out? How do we digest or ingest all of that output to create knowledge from that? Knowledge that puts us on a path on whether or not there's a vulnerability here that can be exploited with some high likelihood. So how do we make ourselves more efficient at ingesting all this data? An interesting paper that came out of Mars Science Lab, by the way, when MSL, now Curiosity, it's on Mars, was Holtzman had wrote about their development approach. And you can talk about specifics and all that. The theme that I thought, wow, this is pretty cool, was the combination of tools, if you will. I'm using tools generically in this sense. Tools that were used, meaning they use static code analysis, they use model checking, they use unit testing, and I'll just stop there.
but it was basically, it wasn't one thing that led them down a path of whether something was going to work or not work. So how do we use other analytical tools in our toolbox to complement our static code analysis results? And can they give us insight so that we might be able to weed down or weed through all of the output that these tools throw at our analysts? So it's really I mean, we got several paths that we might go on, right? Parallel paths. You can come up with unique filtering techniques to kick out some of the results. Or another path is, no, let's ingest it all and figure out a way to do it real quick. The other thing that's, especially when we're talking security, right? And there's a fine line between a vulnerability in code and is it a security vulnerability or is it a vulnerability? I mean, it depends, right? So when you do look at a lot of the exploitations and you see some of the underlying causes, these tools can't find all security vulnerabilities. Some of the real neat ones are a combination of events that have to occur. Some of them are triggered by a very low severity issue that maybe a code analysis tool would have flagged. But it requires a lot of events to be combined for the exploitation to be actually realized. So, what are we doing about that? If we're just employing a static code analysis, are we going to be able to find all those hot vulnerabilities that are out there? I don't have my, and then the other one was, in trying to ingest all the data was, we did, NIST, and Dr. Kuhn left already, but NIST has a group called Summate, and one of their goals is to evaluate static code analysis tools for security purposes, to identify capabilities as well as limitations. And so, and we did, Katerina and company did research a year ago, 2 years ago as well, that even complements their work, and it says, well, look, if you're only running one tool, then you're missing a lot, because these tools find different things. And so hence, our toolbox in the program has a suite of tools. Now again, though, you're challenged with each tool is going to produce a ton of output, so now you've just compounded your problem. So how are we, again, back to the common problem, how are we getting more efficient at using these results? Another interesting topic, because the tools are also evolving towards this direction. Maybe if I have some SWAT folks in the room, they could elaborate a little bit more, our tools group. But a lot of our code analysis tools are built to run on parallel platforms. And so will utilizing those types of platforms make us more efficient, be able to analyze more of the build, crunch more of the output of the results of these tools. These graphics processing units and these boards that are used today are extremely powerful at crunching data. You see the gaming and the image processing world migrating to these types of platforms because they're stellar at crunching data. And we see our static code analysis tools having configurations so that they can run in these types of environments. And so will that, we have not tried it yet, but will that give us some advantages if we run these tools in these environments? And then the last thing that I'll end on, but let's continue the discussion here right now, is actually utilizing the power of these tools. There's a poster over there from our multi-purpose crew vehicle folks to where MPCV has a coding standard, just like, if not all, most of our missions do, has a coding standard. And so our tools are extensible. You can write your own rules so that we're no longer a slave to whatever rules that these tools are built to cover or search for. The minute you buy the tool, it finds these types of rule violations. How do you extend that set of rules that it checks for? So how do we use that capability to extend the rules that it's checking for? And from a security perspective, each year you see the top 25 most dangerous, or I think that's the title, most dangerous programming errors. Humor me on that. So if there's a top 25 that is not one of the rules that one of our 5, 6, 7, 8 tools that we throw at the code, if one of the top 25 is not checked by one of our tools, what are we doing about it? Hence, you heard Rick's discussion earlier about Heartbleed. That would, if you're using one tool, more than likely you're using one of the tools that can't find Heartbleed. So what are you doing about it? Are you waiting for the vendor to try to patch their solution? How are we adapting to writing our own custom rule checks? And you're going to see that some of the limitations, I think they titled it limitations on that poster, was learning the unique scripting language of these tools can be a hindrance because it's something else we have to learn and maintain that knowledge. So there's limitations of doing it, but there's also some benefits of doing it. But where are we having the discussions on whether or not we should proactively engage that? And then the last point is, especially from rule generation, is if we think about it as a program, we have been collecting, if you think back to the Pitts days, we have been collecting issues about software since the 90s. So we have an issue repository of unbelievable information that can create knowledge. And so how are we utilizing all those past issues, that the mistakes that have been made in software from all the different projects we have looked at, how are we using that to generate our own custom checks so that we can turn around on today's missions and tomorrow's missions and say, well, there is a likelihood you're going to have a software bug. However, we can confirm that you haven't made the same mistake you've made in your past. That would be very powerful. But again, that's challenging from a learning how to extend these rules that these tools do, how to connect it to our issue repositories so that it's an efficient, streamlined process now. So, I don't know the formal process here, but again, we really don't want to treat this as a report out. This is a chance for us to discuss so that paths can be put in place that we go down the direction of what should we be doing next, as well as, or just hearing about other challenges that folks, might be wanting to talk about. So I'll hand it off for those purposes.
So anybody in the room that would like to ask a question or open discussion, step up to a mic. Please speak directly into the microphone because it does have a hard time to pick you up. And then anybody online that's listening, please put your Q&A in the Q&A window and we will read those out loud.
So I've got two. So all I've heard is static code analysis, but so what kind of warnings were the 3 million lines of code? How many warnings did their normal build put out? And did they have all of the warnings turned on that they could have? Or
Yeah, each of the tools has their own unique sets of checkers. For this particular run, we had all but certain select standards checkers turned on. So out of the 100,000 messages, I believe there were, I don't have the specific data in this.
I mean,
this
how many in the normal build environment, did they have all the warnings turned on, and was the development team actually paying attention to them?
They actually did not have a static code analysis tool integrated into their development environment until after we had done this analysis and provided them the feedback showing that there were a significant number of true positives in the 4,400 messages that we actually put eyes on. But we made the point that there was 96,000 messages that we didn't look at, and buried in that could be potentially some severe coding errors that they would need to address. And as a result of our presentation of the results of our analysis, they decided to integrate a tool into their development environment that would help them identify these as they're coding them, as they're checking the modules back in, so that they would head off potential errors that we would then find in their software.
My other question is, we noticed in looking at the static code warnings on our software that the parts that gave false positives tended to be the parts that were hard to understand as a human, and that often rewriting the code in question to actually be more understandable, even though it was a false positive, it didn't confuse the tool, and it also got rid of the false positive at the same time. And I heard there was something yesterday about automated tools, the automated generated code wasn't finding any. I'm curious, because automated code tends to be really human ugly. And I'm just curious if we trip that. I mean, any comments, any thoughts?
I don't have any experience with the auto-generated code. I'll let Rick handle that one.
Yeah, I was going to say that we do have some pieces of software here that do auto-generated code, and it becomes somewhat of a manual effort to be able to map this stuff. And a lot of times going back to the developers and telling them to rewrite that doesn't go off well, because they're expected to put it in this format. The requirements are there. They don't want to change them. You and I have talked about that earlier, and I think that one of the biggest challenges we have with that is we can tell them from a maintenance standpoint, this does what it's supposed to do. And we do develop maintenance, we call them TIMs, but issues based upon this. And so that's one of those things that if it's hard and confusing, and it's actually something where if they took a piece of the code and tried to reuse it somewhere else, and it didn't, wasn't the full piece of the picture, so it may not work the way you thought it would, we definitely do write those up as issues. The thing is too, I mean, we see that all the time with auto-generated code where you may have this infinite loop, but really it's not an infinite loop, but because of the way that it was system generated, it's, it handles it, it knows what it's going to do. But yeah, we do see that a lot, so.
I think we can hear you.
I'll just walk over here. Well, yeah, they can't hear me online.
Good point.
It's too short.
It is dead. No, it's not dead.
I'm Pat Olguin, GSDU, IV&V. So 2 questions. Marcus, you opened a can of worms. As far as what are we doing with old issues, TIMs, and so on, I'm curious what, if any, plans you guys have for defect analysis, particularly like root cause. And I'm talking about root cause in the development process, if you guys have any thoughts on that.
Well, I don't know if I am on the same frequency exactly as, root cause of the defects on the development side. Maybe, let me try to, if I don't get it, then redirect me here, but so some years ago, I think it was when Crumley helped me out here, when Greg Robinson, I think, was in the chief engineer's office. Was it Greg? So it was about that time frame, and I forget the years, but one of the things that he actioned us a lot with, this wasn't necessarily on the developer's defect repositories, it was more on the issues that we raise against the defect, against the developer's code, was sure you have these unique issues or unique instances of code that has a vulnerability. What's the common theme here, underlying them? So that from the chief engineer perspective, we can start putting out maybe best practices for programming instead of trying to resolve a specific instance of an issue. Let's try to generate the common theme. So that went on some. We did go down a path of how do you take a specific issue and automatically generate a rule. And what we saw was 50-50. Some of these rules you can't automate. Or some of these issues that you find, you just can't automate a machine to find. From the developer's defect repository, I personally haven't had any luck in getting insight into their defect repositories to try to do a similar investigation. Maybe some folks have, but that's typically the wall where I know my involvement has ever been. We've done some work with like Robin Lutz and company. I think Robin's from Arizona, I think. Iowa State. And I think, and Katerina, you did some work
Yes,
on that as well, where they've looked at developers' issues. But from our program perspective, it's very tough to break into the developers' defect repositories. So I don't know if I was touching on it.
No, you are. You're touching on it. I was trying to get to is, I mean, we used to, within, I think it was as far back as PITS, we had the concept of like it was more detailed in the issue type. I mean, there was actually, we would have a generic description for, array bounds overflow, or, those kind of, I mean, enough detail where you can tell specifically at least what the coding issue was, and then maybe speak to something about, so you can look for trends in the problems they have writing their specifications, because we find the same things over and over in ambiguous, use of a word like accuracy or, tolerance or something like that, where we find these, I mean, those of us who've been here around a long time, we find this, the same thing over and over. And I was wondering if part of this, the use of the old issues, if there's a potential to at least feedback to the, the developers, so they can say, look, we find these kind of things over and over. This is a systemic problem we see from project to project. Because those of us, we see this stuff. It come, it just, this kind of thing comes up, and I'm wondering if there's something we can do, because it's definitely static analysis, whether it's requirement or code.
Actually, Pat, what I'll say to this is one of the things that we did is there's been some efforts here to actually take the TIMs and try to categorize them. So we've done that to try to determine where the defect analysis is, to say what's the most common, what kind of problems are we reporting to our developers. And then on top of that, we take that data, and I've talked briefly about it, but I actually created a list of tools and then all the different types of checks that we would have based upon what we've written. So we continue to add to that. But yeah, the attempt to capture the data from our TIMs or the issues that we write, we did that quite a little ways back. Actually, Dan Painter worked on that a little bit. But the thing is, it's now we're trying to find ways to categorize that. In some of the ways that we collect our data, there is ways to capture the tool and the types of problems. It's not on the main page, but there's other tabs.
Yeah, that's how we handled it on our project. We had the SWAT folks create a special tab within Orbit where we would identify the tool, what checker was the source of the issue, and capture some of those kind of metadata type things so that it would be easier to query, how many buffer overflows were found versus how many memory leaks were found.
Right, because your tool gives you that, will give you that report. So,
Yeah,
all right.
actually, there is a lot of information in the issue tracking system, and it's worth digging in there and finding trends. And I had some experience with my former PhD student working, Maggie Hamill, working on a NASA mission, and we came up with results that were, and the IV&V people for the mission were really very helpful and instrumental of helping us understand the data and the impact that has. But it really shows interesting trends that you may not be aware. Things like a lot of on-orbit critical, or in general, critical faults tend to be coding faults. So you wouldn't expect that may be the case, but it is. So there are a lot of common trends, and the data analytics is very valuable. Within information assurance, or in general within quality assurance, especially when the data is already there, there are things that can be done across missions. Maybe one mission can learn from the prior missions and avoid proactively things that tend to be there as a trend across multiple missions. So
It's a great question. I mean, and we got a lot of mission folks in the room, so it would be interesting to hear how valuable would that be if they had that on day one. Hey, look, over the past 20 years, or maybe let's not do it that way. This type of mission, this type of developer, these are the types of themes or trends that we have found in the code, the top 10, if you will, for you to take forward on your project. And it's based on how we've data mined our repositories. I think that would be it'd be interesting to find out how useful our folks would find it.
Yeah, I mean, it may not be the top 25 most dangerous software errors or security problems that you guys use, as a filter. And then my other question, and I asked, matter of fact, it was the security people yesterday, is especially with Rick's presentation this morning, is what, if any, or if you've thought about doing code analysis when you have the source code for a development environment, or in this case, it was communications for SSL. That's something, now that we've stuck our foot in the door of information security, then you can introduce a problem because there's a bug or a virus or something in your development environment could creep into your operational system. So I'm wondering if you guys have thoughts on that.
So just to clarify the question, so you're asking if we've got some sort of way to try to determine if the developers can you rephrase the question?
Well, the concern now that IV&V is involved in information security, cybersecurity, information assurance, right? This is a big umbrella that we didn't really used to do before. It seems to me that the actual developer's environment, from his use of SSL and maybe in a corporate intranet to other COTS tools that could be infected, because it happens all the time. And so, is this something that we that we might want to consider when there's source code available? Because there's a lot of open source tools that developers use, and if that's something that we need to consider.
Well, I'll actually say this. I mean, we see this all the time with a lot of reuse code, right? I mean, we've had a lot of times we assume that it's been reused on this or that. So that's one aspect of this. It's just saying, there's a particular piece of software that may have, been used before. Was it perfect? We don't know, but it's been used before, therefore it's okay. The same kind of thing happens with logic. We say, okay, well, this piece of logic looks good, and we're using it in 3 different pieces. It may not be the exact same logic. It may be the way to do something, but yeah, we definitely need to think of things like that. And we've actually started thinking of static code analysis a little bit from a design perspective. Saying, for example, let's say someone develops a piece of software that, let's say, does altitude control, okay, attitude control, and we have that. And it's been done a different way, or maybe a similar way on a different project. The question is, if we find a problem on one of the areas, it's worth our time and effort to go back and take a look at the other project if it's still going on, to say, hey, you guys may be wanting to know, whether or not this is an issue on your guys' project. In addition, take a look at the different ways that things are designed to see why maybe, one project may have double the lines of amount of code for the same functionality. That kind of stuff also comes up to say, is there extra code here? Are you guys trying to cover a couple bases? Is it particular to the project, or is it just something that, is a little long-winded? I mean, those things are all valid.
But now, with that, are you also asking that something like, you have a development environment which has multiple things in it. We are looking at, the code being hacked out, being written, but there are other components in this environment. And so it's kind of like when we scope a system and we look at all the subsystems and we say, well, we're going to look at this one. So in this entire built environment, is that entire environment our scope? And I think that's the area, and I think that's what you're hearing is, I think there's been some chatter about it. I think that's a real tough nut to crack in the sense of, you don't need to be looking at these things over here, the common response. And a lot of that won't give until we start seeing things fail because of certain components in the build environment that probably should have been looked at. It brings up an interesting combinatorics question that, Kuhn talks about at NIST from a, you might have very not high severity types of coding problems. It's really not that big of a deal. But combined with something else, maybe it is a bigger deal. And that's hard to cognitively, wrap your mind around things like that. So I don't know if we got what your question was, or if the group has another type of response.
I actually have a few things to share online. First, with regard to your former question, Wes Deer says that he thinks it would be a fantastic idea, a fantastic starting point for IV&V projects. And then he also indicates that he and Rick Hess had talked about this to some degree and think that having a cheat sheet of sorts would be a great starting point to expand upon for a given project. With that, we'll continue with this question in the room, and then I have another point to share from somebody else.
this question is mainly for Katerina. You mentioned a tool, the Escape, which is the tool that allowed you to collect results from various tools and prioritize the findings. We saw an earlier presentation today that took the output of two different tools and used the common XML format to bring it into a spreadsheet. Does your tool build on something like that, where you then go further and analyze results from that common format?
So at this point, no, but that's one of the things that we plan to do by the end of this calendar year. So the tool, Andrei is here, Perchinsky, I might give him a credit. He's my graduate student that works with me on this tool and the one that actually write the code for the tool. So currently we do use only one output from one tool, but what this Escape does is organize, rank, prioritize what the analysts are supposed to look at and support their decision making. The problem then Van was posting, if you start with 100,000 messages, how you end up to the 4,000 that you have money and funding to cover. That is one of the things that we plan to do because the tool is generic. The fact that now uses only output of one tool doesn't mean anything. And one of the steps that we plan to do, assuming that the funding for FY15 goes through, is to make the tool work with multiple tools. And then, as Marcus was saying, and as we saw earlier from our and CMate analysis, what really happens is there's overlap of tools reporting the same vulnerabilities. There's also complementary. They report some and others report, one tool reports part of the vulnerabilities. So one has to be really very clever because you may have higher assurance of multiple tools, but you will also have more messages to look at. And the goal of what we try to do is to provide automated support to the analysts and peer reviewers in their job of trying to prioritize where they should spend their time, as well as to do that in an adaptive way. Once you have done 25% of your messages, that tells you something using machine learning and other methods. Does this help you to maybe redirect your attention for the next 75 that's percentages that you should look at? Is this answering your question?
Mostly. I did want to ask one further question. Did you use Van's results to benchmark your tool, like the 100,000 to bring it down to 4,000? Did your tool assist in that?
No. Well, actually, that was the motivation of the work, among the other things that initiate the stuff that we did.
Okay.
Because once NASA moved to ground projects that are much larger, and you face issues like this in conversation of Van and myself, we figured out there is an obvious need to make this whole process of prioritization more efficient. So no, they did that on their own.
Okay.
But what we are trying to do, Van was part of the team that met bi-weekly and have the output from projects like these and from civil servants like Brendan Bailey to how to actually tailor this to the process that's used in NASA.
I'm on a mature project, the ISS, and only recently have we thought about running all our legacy code and the code that's been around for a long time through the code analysis tools. So there was one that will handle ADA, and there's only one tool that does that I've been told of, CodePeer, and we may, or I don't know, I haven't run it yet, but I suspect we'll get a lot of results, and maybe something like your tool might be useful, especially if you're going to have it online in the next year. So.
Sure, the tool is even now available. I mean, there is a working prototype, and
okay.
I think that would Brendan be the right person, Marcus?
Or you can get with Diedrich and SWAT.
Oh, okay.
Right.
All right, well, thank you.
I have one other notion to share from online. Sarma shares in his opinion using a tool for standards checking is redundant since the project will do that as part of their requirement. The analyst is better off using the tool to find software vulnerabilities. I don't know if anybody has any comment on that, but I also have another statement online. The speaker said that only CodePure works for Ada. Polyspace also works for Ada. Anybody else in the room?
Hello? Okay. This actually might work as a good follow-on to your question because I'm the person who gave the talk this morning about combining tool output into a single spreadsheet. I've actually already been contacted by Brandon Bailey about using that with this escape tool. But what I actually wanted to talk about was I'm noticing that we seem to be making a transition from using spreadsheets to using databases to store our data. Not just with static analysis, but with even analysis of documents with the analyst workbench and so forth. And it's more of a comment, but I think that's a really good idea because we don't tend to save a lot of data from old projects. Like all the stuff we filter out, we just kind of drop on the floor, and then the only data we have to look at in retrospect are the issues that we actually support to or report to the customer. And so if we're putting all of our static analysis stuff into a database, we can come back and run queries on it later and find out things that we may not have known, like which checkers have higher false positives, which ones have higher false negatives. Say if tool B catches this bug and tool A says they do, but they don't. We can find out things like that. We'd have a lot bigger data set to look over. So I think it's a good plan to use things like the escape tool, and the next time I do a analysis activity, I hope to use it.
And Ben, I'll address that. You make a very good point about there being some data lost during the process of doing the analysis. When the analysts have completed a set of messages and they've found and identified them as true positive or false positives, passed off to somebody else to do a peer review. If it's confirmed to be a false positive, kind of pitch that away because we're only interested in the real issues, and that's what eventually gets imported into orbit. And that's kind of why, working with Katerina, we've got it so that the roles within the tool, being a project lead versus an analyst versus a peer reviewer, the peer review is captured, the historical record of whether it was identified as a true or false positive initially, whether it's changed states from true to false or vice versa, is captured along with the peer review comments on that. So I think you're right. We're going in a direction where we're capturing all of that data that will then help us, support an assurance statement on the work that we did.
Yeah, and I think over time it'll help us make better comparisons between the different static analysis tools, right?
And actually, the tool currently takes the need for writing an SQL queries because it has a GUI which allows you to say, give me all CWEs of specific number, or all that are from this checker, and it's flexible in the way that you can have different views per checker, views per file, so you don't really have to do all the manipulation in a spreadsheet or SQL queries. That's done through the GUI, and it's supposed to make the life easier, and it's supposed to be adaptable. So as you go, you can change based on where you are seeing true positives or false positives, change your focus from one place to another if you feel that. And we did some, and the tool also output some machine learning results that provide you more than just this checker, maybe combination of a file and checker that typically leads to true positives. So you better look at that file and that checker. So it's just a support. The analyst is still going to be there, and the analyst is the one that makes decision, but takes away the things that you have to do manually by supporting them and providing more flexibility and some intelligence from data mining.
That's all I had. Thanks.
I have a question from James Hilly online. He'd like to know if the original exported spreadsheet from a tool like Clockwork is still available somewhere.
Would you mind?
He says the original exported spreadsheet from a tool like Clockwork should still be available somewhere. I don't know if that's in relation to the discussion we just had or if he's asking that directly.
So what this toolscape that I mentioned does is takes the output from tools like Clockwork and as an input and then uses that. So the output from Clockwork is still available, yes. And the tool, in addition to the database, also has export import functionality, so you can still do things in spreadsheets if that's what's the goal.
Thank you.
Yeah, if in the future the development organizations adopt these static analysis tools themselves, what information should they give you at IV&V so that you and them can together do the most efficient use? At least they should tell you, I presume, what tools they've used and what rules they had. And maybe should they tell you which of the false positives they already dismissed so that you don't have to tell them the same thing over again. So I'm wondering what extra communication should the development organizations be having with IV&V as these tools migrate into their facilities?
Well, I mean, all of us can throw some ideas out there as far as, well, first of all, let's set the stage because they're doing that. You know, these missions are adopting the same tools that we're using to some extent. So number one, certainly how they're configuring and running their tools. Because these things, number one, they just don't run, you know, take the wrapper off the box and push the button. That's not how these things work. So how they configure these tools, as well as what types of things they're trying, you know, rules that they've got turned on, the things they're chasing down, that's certainly very valuable. And it's, to me, it would be valuable to discuss why. Why would that be valuable? Now, from a minimal perspective, just so we don't repeat, you know, we don't want to potentially spend the same, you may want to, but spend the same amount of effort. But I wanted to pull on the thread a little more from a purpose of it might trigger additional type of analysis, knowing what types of rules that you're looking for. That we might be able to complement, like from a testing perspective, meaning we understand the rules that you're not checking for and we understand the rules that you are checking for. So the ones you are checking for, you know, it would be nice to see what your results are to see if that does flag anything, because that might change some of our testing perspectives, that we might not want to test those particular components or something. I don't know. But certainly how it's configured and the types of rules, I think, would be very valuable.
No, I would agree, Marcus. You know, you certainly, if it's a case where a project adopts a tool that we have in our toolbox, then we definitely would want to know what version of the tool, make sure that we're not running the same version, not running the same checks, and that might influence us to pick a different tool. And somebody yesterday had presented, I forget who it was, but you know, originally on one project we used Flexilent, and then the project adopted Flexilent, so we moved the Clockwork. They moved the Clockwork. You know, they're kind of chasing us, but we're also trying to get ahead of them too.
Well, for more discussions, because it does trigger, I mean, it's a great scenario because then it plays into the use multiple evaluations, multiple tools to analyze the code. If you know the mission's using tool X, we haven't really seen, at least I haven't, so speak freely, where development has adopted the concept of buying multiple tools, you know, and really investing into all of the multiple suite of tools. You might have one or two out there, but so with that, if developers are using a certain tool set, then we can certainly complement that so that we can beat up the code a lot more, because we know that tools find different things. So that's number one. But for the group, it would be interesting, what if, you know, it'd also be beneficial so NASA doesn't spend the money twice, right? So let's be smart with the taxpayers' money. But if developers do start employing all the tools we use, I think one thing that I can certainly improve upon as my role for the program is it's more than just running a tool. And I think sometimes it's that message that I don't do such a good job in annotating to the world, as far as it's more than just buying. Just because you go buy a tool doesn't mean you're secure. And that's a tough picture to paint. And so I think from a group, it'd be interesting to how would we adjust if every project that we have in-house starts using all the tools we use. What do we do? Let's tell that story. I don't know.
I was going to say, one of the things that Marcus had just touched on that I was actually also going to touch on was the fact that we have analysts here that do this. This is what we do. So the good news is that we have guys that are properly trained. Now that doesn't mean anything. I mean, the developers, I'm sure, are going to be able to kind of check their stuff as well. But there's a reason why we have a peer review process here, is because there's multiple times where we're checking for things. And a lot of times they may be just running tools, whereas we are actually looking for specific defects maybe. So we're coming at it from a different angle in addition to all this. And there's been times, and even Van can tell you from JPSS, where manual analysis has been done. And the thing is, it's one of those things where we actually go through and try to check and see what kinds of things we can find with these tools. And even if you had 8 or 9 different tools, there's probably still going to be things that you can't find. So then you got to determine how to cover those gaps and do manual analysis. So those are the kinds of things as well that we can kind of try to help with, because static code analysis is great. It doesn't have to be the only method to do things. We also have, I work for the James Webb Space Telescope. I'm the ISIM lead for that, and let me tell you, we use the independent test bed. It would be great. We've actually used it to validate TIMs that we've had for code analysis to show the actual impact. So there's some things that we can do utilizing not only static code analysis, but other things to try to incorporate, to try to validate some of the issues that they're finding.
I think one last thing that you triggered, Martin, was I think another thing, maybe we did say it, but from a developer's perspective, and this would be very hard for them to answer only from a political perspective, what didn't they necessarily address from what the static analysis is showing them? And the one reason why, to me, that would be very important or insightful is because from a security perspective, information assurance perspective, we've seen that these tools don't find, I'll be provocative, it's sometimes very poor in finding security vulnerabilities in some of these results. And I won't put our results on the line, but you go to the SUMATE group, and yeah, in the Juliet test suite, these tools don't find a lot of the vulnerabilities that were seeded. So to find security vulnerabilities, even if it does flag something as a potential coding violation, it might be trivial from a severity perspective, a categorization perspective. So on a developers, if they're running our tools and you look, these category of a 3 or a C or whatever the nomenclature of the day is, we're not addressing those. That still may trigger evaluating it from can this be used to exploit the system? Meaning it's not going to lock tasks up on the board, or it's not going to cause anything like that, but can it be used to exploit the system? And so it'd be interesting to know what they're not addressing.
I think that it's an interesting subject that's been brought up here, and if someone else has referred to this, I apologize, because as you all know, I'm a little deaf, and sometimes I miss some things. But one of the things that's been repeatedly mentioned is making use of our database of issues. And while false positives are a real pain in the tail. I mean, sometimes I heard mention of 200,000 on one run here a few minutes ago, or I thought I did, and I've gotten in numbers close to that. The real issue is false negatives. If we could do, you know, you've been mentioning this too, Marcus, here about they don't catch everything. Well, if we could maybe start maintaining a database of things that we know our tools don't catch, then perhaps we could find alternate mechanisms to find some of these things. You know, if we know our tools don't catch XYZ, then we come up with another way to catch XYZ.
I mean, one of the things I think you're highlighting to me in my mind is what's next. You know, how do we find the next problem? I mean, our job is to break the system, right? I mean, boil it down, not to trivialize it, but so how can you break the system? Well, we have some standard ways that we can look for things, these rules that we keep mentioning, that the tools will help us automatically detect. It's good, bad, blah, blah, blah. But what's the next way to break the system? We talked Heartbleed earlier to, well, what are we going to do with this information now? You know, how is it going to make our knowledge bank so that we're automatically checking for it? It's an old virus that exists out there, and it's not really an exploitation, if you will, but to where the code morphs itself but maintains the one true function of replicating itself. But when it's loaded on your machine, it literally changes all the lines of code but that function and recompiles itself. And what it's doing is it's slipping through the detection systems because it won't match a pattern. It doesn't have a pattern because it changes itself, except for that function. And it's an old virus that's out there, but I was reading about that algorithm just because it's pretty cool. But you know, what that does is it just says, how are we going to find that type of problem? How do we adjust in real time and find the next greatest problem? You might not be able to find all those instances, but the true litmus test is, are we able to do it, first of all? So that we're not too slave to just chasing down all the standard messages. Are we able to, you know, evolve and try to figure out what's the potential next bug and how can we help our analysts, not necessarily automatically, because we're not taking them out of the loop, but how can we help them put the tools in their hands to find the next problem? So databases, retaining this knowledge, information so we can create knowledge, that would be awesome. I know you guys are talking about this for some time. You know, how do we put that though in play for the whole program? I mean, let's continue the discussion. What else?
Yes, this one's a little bit more from a project management perspective, and it's towards Marcus, where you did have the various databases where you were collecting those flaws, and I could just kind of imagine mounds and mounds of materials. And then on the other side, I saw, and I'm not familiar with your particular system, and I don't want to go into anything proprietary that you can't talk about, where you're lifting information out of reports, and I'm just curious, how is this all kind of going back into your lessons learned category? Because I've seen this at a couple of places actually, where from a project management perspective, the lessons learned maybe gets a little bit neglected during a project. Sometimes it's not filled in at the end. You have analysts putting technical material in a database that they're aware of, but the project manager might not be aware of it. Do you kind of understand where I'm going? And then you have material coming off reports. How is this all being correlated? And do you have a team that's specifically like a PMO that's specifically keeping watch on this, or is it kind of departmentalized type of a thing? I guess it's the flow of information and how you're managing it, because I see, I guess, two aspects. One, where you have a lot of information and analysts that are very skilled, but I don't see how that's kind of trickling over to your PMO group. And then the feedback I've had on your lessons learned, which is not kind of unfamiliar that I've had with a lot of other clients, is it's maybe not where they want it to be. And now you're coming up with tools that's pulling information off reports to kind of get it there. So
So, I mean, actually, I'll let others.
I know it's a combination in
Yeah,
there, so yeah.
because there are some things that I know I can't do justice for, and that's at the project reporting level, that these guys and gals generate lessons learned. They write their monthly reports, and then they write their closeout reports from projects. And so, I'll let them characterize, how that information flows from that perspective. The one thing, keep in mind, we do have a knowledge management initiative within our program, and it resides in our strategic communications office. And one of the things that it's, the focus or purpose of that group is to make sure that information is being captured, retained, and knowledge is being generated and used and integrated back into the program. Now, that sounds nice, and that's tough to do organizationally. So it's hit and miss. We have successes and all that. We could. I think some of the things that's being illuminated is, number one, I think we're very good. This is personal opinions. I think we're very good at capturing data. We can always improve in that area, like we mentioned, databases and whatnot. But I think we're very good at that. We've got a history of issues that is just there is no organization in the world that has a knowledge of how software has failed over the years than what we have in our databases. I mean, that's crazy. Now, tapping that and creating knowledge, that's a challenge. I mean, it's solvable, but it's not done without cost. So I think information flows. Sometimes we create knowledge from that information. Sometimes it passes through our grips. But I don't know if anybody wants to elaborate from a project perspective on how information flows. But
Well, just from our project perspective, we did generate lessons learned, and it's logged in the lessons learned database here at the facility about the challenges that we ran into on this. It was a large code base. It was multiple programming languages. It was proprietary software. We had to do it on site at a developer location. So we had a whole lesson learned about all of that other projects might encounter. There's increasing requirements to do the code analysis at a developer site, and we've learned some lessons about how to do that and do it smartly. So we do capture lessons learned as part of the work we do.
If you don't mind me asking, while you captured them, did you simply capture it at the end of the project, or did you file throughout the time frame of the project?
We made a conscious effort to try to do this along the way. We knew our situation was a little bit unique in the history of the facility, so we had a cognizant effort to address this along the way. We shared those lessons learned with the developer because some of what we learned was in the context of working with them and how to better work with them in the future.
Did you find, prior to project commencement, the lessons learned database, was it relative? And did you pick in there before you started your project, and how did you?
We did some data mining there. We also talked to some of the other projects that we were aware of that had gone on site to do analysis and, kind of learn from them that way.
Yeah, and from a general, and I know she's getting ready to cut me off, but from a general perspective, I found that, and I'm a consultant, so I've worked at various companies, the word of mouth is sometimes better than what's sitting in the database and drives it along. But if we could come up with, I guess, a happy medium or something, along. And I think one of these guys had an awesome idea with having, when they were sharing their tools, when the project starts up, here's the tools we have. Can you share one of these? And then if not, but something procedurally for the analyst level as well, for them to kind of be aware and thinking in that direction too. Because sometimes the information doesn't quite get to where all channels are
Well, I will say one thing, which is, one of the things that we do have here is this static code analysis working group. So we're supposed to be working with the other projects to capture these lessons learned and try to validate results. And one thing that Charlie Adkins had pointed out was, the false negatives, for example. The things that we're actually trying to do right now is, try to create this database of different tools and different types of checks. And then when we have problems like what Van has had, we're trying to work with them. And in fact, one of the things that we're trying to do is there's this software quality objectives document that we're trying to write, which is a process that new projects would be able to start up, which is what Wes was talking about. And so we're trying to integrate that. The real big question that we're having right now is, making sure that we can lock down a template process and then say for each project, you can vary on this and that. But we're trying to help fix problems that have happened in the past, or maybe help, guide a new project lead to try to figure out how to do static code analysis instead of it being, the way of the wild and you just pick a tool and run with it. We don't want to do that anymore. We want to be able to look at the different types of checks that are out there and determine what's important for the project, maybe by specific set of rules that they want to go by. There's things that are called golden rules that we look at, which are important for each project. And so they vary. And the thing is, using those, and then also other things that the project may find important to determine whether or not, what tools we need to use, and then for those coverage gaps, also what kind of analysis do we need to do there, and trying to work with that. So there is process going forward and trying to capture these problems. And so our group's actually trying to do that. So we get these analysts together and we're trying to do that. We also have biweekly meetings. We also have technical meetings that we have every week to try to facilitate people to discuss these kind of issues. So we're definitely trying to communicate out there. It's just making sure that everybody can participate, I think, is more the problem that we have now. And so as long as we can continue to get participation up, I think that the lessons learned is going very well. So.
Thank you.
Thanks.
And I just wanted to share, I work with the Lessons Learned team within our Strategic Communications Office, and we have been looking at new and innovative ways to share lessons learned in general throughout our program. One of the things we've recently implemented is video lessons learned, so we will record the person who has documented the lesson in our database, sharing what the true core message of the lesson is, and share that with the program. We've been keeping statistics on our lessons learned database to try and figure out where they're being used and when. There are some hooks in our processes that try and incorporate a scan of the lessons learned database for things that are applicable to your project when at different phases of the project. So it is something that it has notoriously been lessons stored as opposed to lessons shared, but we are trying to actively change that, that practice within our program, just from a lessons learned and knowledge sharing standpoint. We do still have some time if anybody else has questions, comments, observations. We will take our 10-minute break.